Hello again, math students. We're going to spend another day talking about just different ways to represent functions. We already looked at a whole bunch of it. And yesterday at the end of the lesson, I talked a little bit about independent variables and dependent variables. So we've hinted at it a couple of times. We're going to talk about it a little bit more yet today, but still just kind of practicing all the different stuff with representations of functions. Oops. So again, the independent variable, that's always going to be the input. That's the variable that can stand alone. It doesn't get changed by other things. That's why in science experiments, for instance, usually the independent variable is time. Like time is going to keep on going, and the experiment doesn't really affect the time. But however long you run the experiment, that could affect what's happening with the other stuff. Another example here, and again, it's sort of still about time, a person's age, right? A person's age is just their age, and it just keeps on going. It doesn't go backwards. It doesn't get changed by other stuff. So it won't be changed by what they eat, where they go to school, how much TV they watch. None of that stuff changes their age. Their age is the independent variable, but their age might affect other things. So the dependent variable then depends on other stuff that's going on. So a person's test score would be an example of this. So the test score could be changed by lots of different things. Could be changed by how much you studied, how much sleep you got the night before, how hungry you were during the test, if you're having a bad day, if you got into a fight with your friend. All of those different things could affect your test score. So your test score would be dependent on all that other stuff that's going on. So if we're just looking at, and I know this isn't a perfect story here, but if I want to know which thing affects the other thing, so we've got a person's test score and the time that they spend studying. So which thing causes a change in the other thing? I would say that the time spent studying causes a change in their test score. But not the other way around, right? A test score doesn't go back in time and change how much time you spent studying. And again, I know there's all kinds of other factors, and I know there are some students that would say, but I never have to study because I learn everything in class. Like, I get that, but I want you to just see that this is one of those things that could be an example. Like, studying can affect your test score, but your test score doesn't go back and change how much you studied in the past. Okay, so is that the right one? There we go. Okay. Some stuff like yesterday. So if I give you statements, you should be able to write these as equations. A function rule is just an equation. The output is 4 times the input. The output, remember that's y, is means equals 4 times the input. That's just 4 times x. There's my equation. It's just translating, that's all we needed there. Remember too, the output is 8 less than the input. We had one like this in the last lesson, but the output is, that means y equals 8 less than the input. We know that less than is subtraction, but it's the tricky subtraction, right? I'm taking 8 away from the input, which means I start with the input and I take 8 away. So there's my translations. If I give you a value of x to substitute in, and we have already done one of these as well. So in number 3, I've got y equals x over 3, or x divided by 3, and x is 12. So they're giving you a value of x. They want you to put that right there. So y equals 12 divided by 3, so y would be equal to 4. It's just a substitution and then order of operations. Y equals 5x plus 9, if x equals 2, okay, there's my 2, that's going in for the x. So I would have y equals 5 times 2, which is 10, plus 9 is going to be 19. And find the value of x if I give you a value of y. So this one's a little bit harder to do because it's not just crunching numbers. We have to actually solve these equations. But this 19 is the y. It's going to go way over there. So 19 equals 4x minus 5. Add 5 to both sides, and I'll get that 4x equals 24. So divide by 4, and x would be equal to 6. Sorry, that kind of got in the way a little bit there. And again, you could certainly check this. 4 times 6 is 24. 24 minus 5, yeah, that's 19. If I take this problem and I put this in place of the y in this problem, I've got negative 13 equals negative 2x plus 7. And then again, I didn't draw my vertical line in the last one, but remember, this is how we would solve this. We get rid of the 7. Negative 13 and negative 7 is negative 20 equals negative 2x and divide by negative 2. So then x would be equal to 10. Okay, here are the last couple of problems. You set up a hot chocolate stand at a football game. The cost of your supplies is $75 and you charge 50 cents for each cup of hot chocolate. Write a function that represents the profit for selling a certain number of cups of hot chocolate. Again, the profit is the dependent variable. The amount of money that you make depends on how many cups of hot chocolate you sell. So for this one, we're just going to uncover this equation. The profit, that's this P right here, the profit is going to be equal to 50 cents for every cup of hot chocolate. And then I want you to think about, why would I have minus 75 right there, right? It costs $75 for the supplies. You didn't make $75 just for buying those supplies. You had to spend $75. So right now, before you sell any cups of hot chocolate, you're in the hole. You are less than zero for how much money you've made. You have to spend $75 just to get the stuff so you can start your business. Now for part B, it says you'll break even when the cost of your supplies equals your income. How many cups of hot chocolate will you need to break even? So after you break even, then everything after that, you start making money. If I want to break even, that means my profit is exactly 0. So I'm actually going to just solve this right here where this problem is. I'm going to say that the profit is going to be 0. So solving this, I would add 75 to both sides. And I've got 75 equals 0.5c. So a lot of people want to do half of 75, and that's not going to give you the correct answer. You could certainly use a calculator on this, but if you divide by something that's less than 1, you're going to get a bigger number. So I'm asking how many halves are in 75, and that's going to be 150. If you can sell 150 cups of hot chocolate, you break even. Everything after that is profit. So today, you have a couple of mazes to do. They're asking, is it a function? Is it not a function? Is it based on like the vertical line test? Is it a function or not a function based on tables? And we've got some where you have to write equations given some different information. We're not going to have a formative in Schoology. This gets turned in class. If you need any help, let me know.